So now that we're keeping track of an axis state, we need a way to actually convert this to a button press and get a value out to determine whether the button is being pressed or not. In order to do this, we're going to need to test the value that we're getting back from the axis itself inside of our axis state. Let's go back into our scripts and open the Input Manager. We're going to create a new enum. We'll make this public enum called condition. And just like we would do normal conditionals in coding, we're going to keep track of the value of greater than or less than as it relates to the off value of the input axis state. Let's add these two properties to our enum. Now, inside of the input axis state class, let's add a new property to keep track of what condition we should be testing for. Now that we have the condition, we actually need a way of calculating the value. One way that we can do this is by creating a getter for the value property. Getters and setters allow us to do additional logic when retrieving a property on a class. In this case, we want to make sure that when we query the value of the input axis state that it's read-only. And one way to do this is by only making a getter instead of having a getter and setter or just making it a public property. So let's create a public boolean, and we're going to call this value. Now in here, we're going to create a get, and now we'll be able to return a value that would act as if we were just saying input axis state.value. We'll start by getting the actual value of the input state axis we defined. This may look familiar from when we were building the simple movement script. In fact, we're taking the same steps that we did in the simple movement script, but now we're abstracting it in a way that'll be reusable throughout our game and also through future projects you want to use it in. Here, we need to make sure that instead of defining it by hand, we're actually going to pass in the value of the axis name, which is a public string. Next, we need to do a switch statement to test the condition itself. And in this, we're going to have two cases. The first case is going to test greater than. And here, we're going to return the value is greater than off value. The next case will test the less than value. Here we'll do value less than off value. And finally, at the end of this, just so the compiler is happy, we need to always have a default return value. So in this case, we're going to return false. Now let's look into how we can actually access this value. Inside of our update method for the input manager, we're going to want to loop through all the inputs that we've registered and get this value. So let's create a for each loop. We'll actually create a value for the input in inputs. And for testing, we're simply going to debug whether the actual input state is true. So here we'll test the input value is true, and we're going to debug log input detected, and we'll just get the actual input button. So here, whenever we detect that the value is true, we're going to return the button that it's mapped to. Let's go back over to Unity and give this a try. If we run our game and we move right, you'll see down here that input detected right. If we look at our console, you'll see all the log traces. Remember, this is being run on every frame. So we're going to see multiple detections as we hold the button down, even for a short moment. Now, to show you how extensible this class can be, let's go back into our input manager and let's map the horizontal -1 to the left button. Here, we're going to extend the inputs. We're going to change this value to 2. The IDE is automatically going to copy the value of the last property we had here, so that now we have a duplicate of these two values. And here we'll make sure that button is left and the condition is less than. And this will now map to the left. We'll save our scene, we'll rerun the game, and making sure the game has focus, let's move to the right, and you'll see right is outputted, and move to the left, and you'll see that left is outputted. So now we can add all kinds of different mappings to our enums of buttons based on the axes from Unity's own input manager. But what we really need is a way now to store these values onto the actual game object we're moving so that the game object knows how to move, and what the current input is.